you kind of get that out of the way. The sample's large enough. Is this a representative sample? Okay. We're saying no. Why isn't it representative? What's wrong with it? What's our population here? Population is implied to be all shoppers at this particular mall. Okay. So we're taking a sample of 50 of those shoppers. Why isn't it a representative sample?
It is.
Okay. Anything else?
It's standing out at one exit of the mall, so it could be by some where there's no good stores.
Okay. So first of all, they're only taking shoppers that show up shortly after noon. Okay. Secondly, they're only taking shoppers at one particular doorway. Now we theorized in the 1 o'clock class that maybe there was only one exit. I mean, it only says here at the exit. In fact, I think that's actually what it says, is researchers stand by the exit. How many of you have seen malls that have only one exit? It's a fire hazard, but if you have malls small enough that there's only one exit, you probably know everybody that goes in and out anyway, and you probably know whether they bought anything or not. And standing there long enough to get 50 shoppers may take you all day anyway, so it might be a representative sample. In fact, it might be a census. For the case that would be realistic, there's more than one exit. Shoppers show up at considerably different times. The implication here is that you're going to pick 50 shoppers somewhere near noon. So the time involved, the location involved is all very much a convenience sample. You're going to end up with very, very biased results. And so we really shouldn't even be using this data. The sample size is large enough if we had taken a good random sample. But we did not get a good random sample, so we really have to question any results that come out of this. Now, the reality is that you will find that this is a very common thing to have happen, is that people will make decisions based on this kind of data collection and apply a statistical analysis to data collected in that fashion, and then make decisions based on that. And the result can be kind of bad. The other thing is, when I look at this, I think about this problem. I think about what exactly they're going to do. They're asking how many or what percentage of the people actually buy something. What are they going to do if they find out that it's too low? Not let you out until you buy something, or make you buy something to get out the door? Or there are places that actually almost do that. They have salesmen that work on commission, on nothing but commission. I used to be one of those. There was a time when I did that kind of thing. But in those cases, when you walk into the place, you want to have a whip and a chair with you to hold them off. I try to avoid them as much as I can. So. But this is a real situation where, in fact, in the 1 o'clock section, one of the people has actually done a fair amount of retail work. And her comment was that they actually have done these kinds of studies, and their bonuses, their jobs were actually on the line to make sure that there was a high enough percentage of people going out the door that were actually buying something. Now, you can be cynical and say the ridiculous ways of doing that, but there are a lot of good ways of trying to do that. And what the company's going to want to do is try to do whatever they can to make sure that when people walk in the door, they walked in for a reason. There was some interest there. And what you want to do is you want to figure out how to take and pique that interest and get that interest to turn into a cash exchange. Or nowadays, very few of us carry cash, so at least a credit card swipe or something. So at least you get some money exchanged. That is a very big part of business analysis. And to base business analysis like this on a poor sample is worse than a waste of time. You could end up going entirely the wrong direction. Okay? Making changes to something that's working great because everybody that comes in the evening buys, you've got a 90% buy rate at night, but the people who happen to walk in at lunch are the people that are coming from nearby stores or from other stores or whatever, or nearby businesses, and they're on their lunch break. They have no intention of buying, they're just killing time. And so now you base your business decisions based on an entirely wrong sample. So you want to be very careful about what you work with. Okay, we beat that to death, haven't we? How about the next problem? 1244. It says to refer back to 1243, and in each of the parts define in words the population parameter P. We almost did that. In order to determine if we had a representative sample, we had to identify the population, and we came this close to actually defining what that parameter is. And part of the reason it's critical, particularly in the case that we're going to get to on Friday with looking at two different proportions, it's very critical to define what each proportion actually means. So we want to make sure we can do that. So in this first case here, when we looked at this first case, the hypothesis was that p is equal to 0.5 versus p greater than 0.5. What exactly did p mean? In words, what is p measuring?
Percentage.
A percentage or proportion. Yeah?
The proportion out of the 20 students that were surveyed that favored the alcohol policy. So the number
The proportion.
of yes, we favor it out of 20.
You're close, but the p is a population value. What you just described is the proportion of the sample. That was p half. So p is
the proportion of the students that are in fraternities, sororities that are in favor of it?
yes. You should also, in this case, limit it to this university. That would probably be implied by the context, but just to be sure, you want to make sure that you're precise in what you're saying.
Does it have to be in favor, or is it like?
In this case, they're specifically asking the proportion in favor, and the alternative is greater than, so it would be looking for a majority. So that's why it's important that you just describe that it's the proportion that are in favor as opposed to the proportion that are not in favor. In that case, you'd have a different alternative hypothesis. Okay? What about B? What does P stand for in part B?
Percentage of employees in the company that are left-handed.
Sure. Now you should say proportion. Percentage would be the value times 100. I probably wouldn't have counted that wrong, but you should be more precise. So it's the proportion of employees in this company that are left-handed. How about C? We decided this was a census, but we can still describe it.
The proportion of stockbrokers that believe the market will grow up next year.
In this company.
Right.
So we have to add in this company to that. We have to, if we don't isolate it to this company, then we're talking about a larger population. So we want to make sure we're precise. Okay, how about D? We can start out with the proportion, right? What is this a proportion of?
People will buy something at the mall.
Okay. The proportion of people who buy something at this mall. You might want to add to that, you're implying the proportion of people that go to the mall that buy something, but you might want to add that just to be more precise. Because you could conceivably interpret that in some contexts as the proportion of people in the city that buy something at this mall. And so forth.
So we can assume that ideas such as the stockbrokers from this company rather than just stockbrokers in general is implied?
In this case, it fairly clearly says that it's just the stockbrokers at this company, because it refers to, it says they are all surveyed to find out whether a majority believes. So that implies they all are the company's 500 stockbrokers.
I mean, when saying what the parameter is, you can't just leave the proportion of stockbrokers and assume that this company's stockbrokers are only surveyed and not any other companies. It's implied. You can't assume that.
Yeah, you shouldn't assume anything when you're writing these out. And that's a little of what we're trying to do here is we're all used to saying things, and we say things very imprecise. And part of what we're trying to do is we're trying to get ourselves to be more precise about exactly how we state some of these things so that we don't have the ambiguities that are showing up. So yes, when you're making assumptions, try not to make assumptions. If you find yourself making assumptions, try to fill in the blanks and make sure that you've got it very precise. Okay.